Hi, I'm Malkov. You already know that Kubernetes is going to drop support for Docker. Starting from version 120 that was recently released in December 2020, you will see a deprecation message for Docker. Docker runtime support will be completely removed from Kubernetes in version 122 that will be released in late 2021, I think somewhere about summer. After that, you will need to switch to one or of the other container runtimes like containerd or cry-o inside your clusters. Despite both containerd and cry-o know how to pull Docker images and run them, and Docker image manifest v2 and OCI image specification are almost the same, nobody knows how long Docker images will be supported. As developers, we need to be prepared to build either Docker or OCI images in just one click and get used to living without Docker. Therefore, I decided to record a series of videos with the general title How to Live Without Docker for Developers. I plan to record 4 episodes, and I want to make them about 15-20 minutes each, so you can learn quickly during lunch or just when you have 15 minutes to spare. If you want to be notified when a new episode will be published, please do subscribe to my channel. Alright, this is the episode 1. In this episode, I'm going to prepare prerequisites for the entire series. I will create a simple web app using the .NET 5 and build a Dockerfile for my application. Then, I'm going to build an image with Docker. And after that, I will show you how to build a container image with Buildah using the existed Dockerfile, just to show how easy it is to migrate your build process for already existed applications from Docker to Buildah. This video is quite short, but you can use the timestamps that are in the description to this video to quickly jump to a specific moment. So, let's start. And to begin, I will switch to my console. And the first thing that I need to do is, of course, I need to prepare my application. I need to create my application. And to do so, I will use the command line. As you can see right now, I'm on the drive C, my apps demo. And here, I'm going to create a new application with the .NET CLI. To create my application, I need to run a command .NET new. Then I will specify what kind of application I want to create. It's a web app. And then I just want to provide a name for my application, which will be, in my case, simple app. Let's call it like this. So I click enter, and in a second, the .NET will create an application from the template. So it will be really basic application. Let's see what it does. So I'm going to run my application to just show you what this application will do if you're not familiar with the .NET yet. I'm going to a folder simple app, cd simple app, and as you can see here is the code for my application, and I do .NET run. To run the application, I need to run the .NET run command. I just click enter. This will compile my application and run. So my application is ready and it's running. So to see it, I just need to go to the localhost port 5001. So I just copy it and I go to my browser where I just type localhost 5001. And in a second, I will see my application. Yeah, looks amazing. But this is just a simple application which has 2 pages, home and privacy. That's mainly it. But it's completely okay for my demo, yeah, because we don't need to write a really complex application to just show how to build an image. Because this approach you can use for any kind of applications, even if you don't use the .NET, it's also possible. Yeah, you just need to use a little bit different commands and a little bit different Dockerfile. But okay, I'm going to build a Dockerfile for my application now. I will stop my application first, and I can prepare my Dockerfile manually, so I can just type everything manually, because the Dockerfile is just a text file, so I can type all the commands manually, or I can take the help from the IDE. In my case, I will take the help from Visual Studio Code. And to run it, I just type code with a dot, so it will actually run the VS Code and use the current folder, which is the C my app demo simple app as a default. So it will open this folder. So as you can see, the folder here, it's our folder. We have all the files. And to allow Visual Studio to generate the Docker file, I need to first generate the assets for build and debug. So I go to the command palette. So inside the command palette, I just want to first of all type the .NET and execute the generate assets for build and debug command. As you can see, it will add just a VS Code folder inside my application, which contains two files, launch.json and task.json. So the Visual Studio Code needs that. And now we are ready to generate the Docker file. And to do so, we go again to the view command palette and we need to say Docker. And actually the command that we are going to run, it's docker add Docker files to the workspace. If I click here, the wizard-like process started. Yeah. So first of all, we need to say which kind of language we use. For example, we can say that we use Node.js or Java or C++. In my case, I use the .NET ISP.NET Core. So I click on the .NET ISP.NET Core. Then it asks for which operation system it needs to prepare the Docker file. And in my case, I'm going to host it on Linux. So I just select the Linux. Then it asks which port should be exposed, and in my case, the 80 and 443 port are okay, so I just click enter. And the last question that it will ask if it needs to generate the Docker Compose files, but actually I don't need them now, so I just click on no, and in a second we will have a Docker file. Visual Studio Code generates the two files, not only just Docker file. It also generates the Docker ignore file. You will find all the files that Docker will ignore and will not send these files to an image. Inside the Docker file, we have actually the multi-stage Docker file. The multi-stage Docker file contains several from statements. So as you can see here, from. So it means that we have three stages here. Why we need it? The best practices say that if you want to generate a final image, you need to use the base image smallest as possible. In our case, for the final, we will use the ASP.NET 5.0 base image, which contains only the runtime that required for .NET applications. But to prepare everything, to build our application, to publish our application, to generate kind of the distribution package, we need to use the SDK-based image. And this is quite bigger comparing to ASP.NET. So in terms of the size, if I'm not mistaken, the ASP.NET 5.0 is about 200 megabytes and the SDK is more than 600 megabytes. So that's why we use the SDK base image just to build and publish our application. And then we use the ASP.NET, which contains just a runtime, as our final base image. So we'll take the result of our publish process and put them inside our the smallest image possible. Yeah. So this is what the multi-stage Docker file does. It's completely okay. So it generated completely well for me, but actually I don't want to have 3 stages. I think 2 is okay, because actually the .NET build command I don't need it, because publish actually also build my application. So that's why I just remove the build .NET build command, as well as I remove the publish stage. So I will just use the build stage and the final. And here I just need to change from publish to build, because we need to copy everything, all the files from build to the final. And as you can see here, so this is the part inside our Dockerfile. It's just a part to build our image, so our application, sorry. So as you can see here, .NET restore. So we're going to restore all the NuGet packages for our application. Then we need to then we execute the .NET publish, which will actually publish our application to a specific folder, which is app publish. It's over here. And the second part that Docker will do, it will take the base image ASP.NET, which contains just a runtime, and will set the work gear to the app folder, and then it will copy everything from app publish folder from the build stage. So this is the build stage, yeah, and this is the app publish folder where we publish our application, and then it will copy to the folder app in our final image. So actually it will create the app folder inside the .NET ASP.NET base image app folder, and then copy to this app folder everything from app publish folder from our build stage. And then it will set the entry point to just instruct the .NET when our container will run, to just instruct the container needs to run the .NET with our application. So that's mainly it for our Dockerfile. The Dockerfile now, okay, so I just save it. And we are ready now to build our image with Docker. To do that, I'm switching to the command line, and let's clear the screen. So we all familiar with Docker right now, and I just do Docker to build an image. We need to just execute command docker build. In this command, I just want to specify one additional parameter, which is the t, which is the tag. I would like to have an image with my own tag. I want to have simple app, and then version, and then the tag 1.0.0. So I just say to Docker, please build my image using the simple app 1.0.0 tag. And the last but not least, it's very important to actually say to the docker build command what is the current context. The context is the current folder which Docker will use to take all the files. Like, for example, we say in our Dockerfile that we want to copy the simple app csproj file first, and then copy everything to our build stage, and then it will publish our application. So to say Docker from which folder it needs to copy everything, we just need to set the context. Yeah, so the context is just a folder. And in our case, I specify the dot. Yeah, I specify the dot, which means that the Docker will use this folder as a default as a current folder. Yeah, for the Docker build process. So I click enter, and Docker will start building our application image for our application. As you can see, it takes all the commands from the Dockerfile and start executing them. Like, for example, it executes the .NET restore for 120 milliseconds. So our NuGet packages were restored. Then it ran .NET publish, which actually will take our application and publish it to a specific folder. In our case, it's an app publish. And then it will just prepare everything. So it will copy everything from this publish folder to our container. And as a result of this operation, we see that the successfully built. So it means that we have an image, and it tagged as simple app 1.0.0. Right now, if I run the command docker images, then I will see that I have a simple app image with the tag 1.0.0. Okay, and the size of this is 210 megabytes because it's based on ASP.NET base image. And as you can see, ASP.NET base image just take 205 megabytes, and the SDK which we used as a base image to prepare our application, to build, to publish, and etc. So it's a 600 megabytes. So it's 3 times less size in our image that comparing to SDK. And of course, it's also kind of a little bit security, yeah, because you don't need to have on your production environments all the tools that SDK provides. So this is also very important aspect of it. So we built our image. We have our image, and the last thing that I want to do with the using the Docker is to run the image, to just see if it's running well, if it's working, and etc. So to run our application, I will use command docker run. Docker run -d. So I want to have a detached image. -d command just tell to the Docker to create a detached container in the background. And I want to open a port, for example, 80. For me, it will be 8080 -p, 8080 to 80. So I just want to map my port 8080 on host to the port 80 inside the container. And the last thing that I need to tell to the docker run command is which image I want to run. And in my case, it's simple app 1.0.0. That's mainly it. So I just click enter, and the Docker immediately always immediately respond with the unique identifier for our container. And right now, if I do docker ps, I will see that this container with this identifier, here it is started. It started 11 seconds ago. And actually the ports for 3TCP are open, and 8080 port on the host maps to the port 80 of the container. So let's test it now. I go to my browser, and inside the browser I just type localhost, and in my case not 5001 anymore, but 8080. And if I type localhost 8080, we will see our app, which is the simple app. Yeah, and we have all the pages, privacy and home for us. So our application is up and running, and we do everything with help of Docker. So the Docker help us to do everything. The Docker help us to build our image and to run our image. The only thing that left is to do a cleanup. So I just want to stop my container. Again, I return to the command line and type docker ps just to see what containers are running. And there is my container that I want to stop. I just copy the first digits from its ID, and I do docker rm -f because the container is up and running. So to stop it and remove it, I just need to force it. And I just specify the container ID, so it will just remove the container. Okay, so the container is gone. And I just go to my Docker images, and here I have a simple app image. Still, I can remove it, but it's not necessary. So I decided to leave it here. Okay, for the second part of this episode, I'm going to get rid of the Docker, and I will do everything using the tools like Buildah and Podman. Buildah is the tool that facilitates building OCI container images. In other words, it's just responsible for everything that you do with your container images. In Docker, we have everything in one package. So the Docker is responsible for images, the Docker is responsible for containers, the Docker is responsible to push and pull in images. In the world without Docker, we have multiple tools to do that things. The first one is Buildah, which allow us to work with images. The second one is Podman, which allow us to run and manage our containers. Buildah contains all the information that you need to know on their website. So they have pretty much good documentation. For example, how to install the Buildah, how to configure it, and then of course how to use it, what command you can execute. You can find everything on their website. So I really encourage you to go and check the Buildah.io. In my example, we have already a Dockerfile. So our application was designed for Docker to build an image using the Docker. And I will show you how easy it is to migrate from the Docker to Buildah if you already have a Dockerfile. So let's switch to the command line. The tools like Buildah and Podman, they are designed to run on Linux. So that's why for my demo purposes, I will use the WSL, so Windows Subsystem for Linux, that I have in my Windows 10 already set up with Ubuntu 20.04. First of all, so as you can see, we are now on my drive C, my apps demo. And I just, if I type ls, so I will see that I have a simple app folder. So I just go to my folder where my application is. So I do cd simple app. So right now I'm looking at the folder where my application is with my Dockerfile. So actually it's everything that we already have seen, but right now from the Ubuntu. The first thing that we need to do is we need to execute the command to build our image. And the command is buildah and then bud. Bud, it states for build using Dockerfile, because this is not kind of native approach. About the native approach, we are going to talk in the next episode. But right now, we will use the bud command of the buildah. So for the bud command, we need to specify some parameters, almost the same parameters that we specify for the Docker. By the way, migrate from the Docker to Buildah and Podman commands is very easy. Why? Because they actually use the same, almost the same commands as the Docker. So if you're already familiar with Docker, it's very easy to you to start using Buildah and Podman. So, and we need to specify the tag, yeah. So which image we want to build. For me, I will specify a simple app, version 1.0.0. By the way, before I run this command, I just want to show you, let's open another Linux terminal. So I want to show you which images we have now locally. To do this, we execute the buildah images command. And right now I have only 2 images. Buildah use a different location for its cache of the images, so that's why it doesn't have the same images that the Docker have. Yeah, so the Docker and Buildah is completely separated commands. So and Docker keep the cache of the images in one place, and the Buildah keeps the cache in another place. Here we see only 2 images that I need to have to build my application. I pre-pull it, yeah, so it's very easy again. So you just execute the buildah pull command, and then you just specify what kind of image you want to pull, like pull Alpine, for example. Alpine, and then it will pull it from the Docker hub. It's almost the same command as you can see, but I just pre-pulled, yeah, pre-downloaded the images SDK and ASP.NET just to speed up the process of the building of my own image. I return back to my console, and here we have the buildah bud command with a flag -t. So this is the tag for our image that we want to build. And the only difference that I need to introduce, because actually the buildah, by default, it builds the OCI compliant image using the OCI specification. And this image, you will not be able to push to the Docker registry. Yeah, and on the next episodes, I'm going to show you how you can push your images using the buildah. So that's why I know that I will push it to Docker enabled registry. So I just want to specify a different format for my image because by default it's a OCI, and I want to build my image based on the Docker image manifest v2. To specify this, I just specify the flag for bud command, which is the format equals Docker. So this instructs Buildah to actually build an image using the Docker image manifest v2 instead of the OCI, which Buildah used by default. And that's mainly it. The only last thing to not forget is the last dot for the context, because Buildah works the same as Docker. We need to provide the context where it can take the files to be to push them to an image. Okay, so I just click run, and it will execute the same process as we already have seen with Docker, but now it's executed using Buildah. And it's done. So our image is created by Buildah. To see it, we can use the command buildah images. So we see now we have a simple app which tagged 1.0.0, it generated 58 seconds ago, and its size 214 megabytes. So it's almost, it should be the same as with Docker. All right. So our image is actually ready. So we need to just run it to test it to see is it working well or is working not well. And to do that, I'm going to use a tool Podman. The Podman, it's a daemonless container engine for developing, managing, and running OCI containers. Again, as a Buildah, it's released only for Linux, so you need to have a Linux distribution to use it. And again, I encourage you to go and check the Podman IO website for the documentation, for the installation purposes, and etc. Okay, let's use it. As I told you before, the Podman and Buildah use almost the same commands as the Docker. So if you're familiar with Docker, it will be very easy to you to jump to the Buildah and Podman. To run my image, I just need to use the same command, which is the Docker run in the Docker world, but we are trying to live without Docker. So the Podman run command will do the same. First of all, let's check what is already running. Yeah, so Podman ps, the same command as Docker ps. And as you can see, there is no any containers running. So I would like to run a first one. I do the Podman run, and I need to specify the same flags like D, so it's detached container will be. Then I want to specify the port for my container, and I want to have 8080 mapped to port 80. And I need to specify an image which I want to run. It's my simple app with the 1.0.0 tag. So as you can see, the command is completely the same. Podman run -d -p8080 to 80 and the simple app 1.0.0. So this is my tag. This is the image that I want to run. I just click enter, and as you can see, we have the error messages. Despite our container is up and running, we have the ID of the container, which is actually hash, but we have the error messages saying that there is a problem with the systemd. I have this because actually I run the Podman in WSL2. WSL, again, this is the Windows subsystem for Linux. This is the Linux kernel that was injected into the Windows 10. And I use it, but unfortunately it's not fully, it's not full Linux distribution. So I don't have the systemd as well as the journald in the WSL2. So to prevent seeing these error messages, first of all, let's see what container are up and running. Podman ps. You see the container is up and running. So I want to just remove the container. I do the same command as a Docker, Podman rm -f. I would like to force because the container is up and running. So, and I just type 117. It's completely enough to identify our container uniquely. I have only one container, so it's very easy. Again, you see the errors, and again you see the image ID. And right now, if we do the Podman ps, we see that the container is not here. So I just stopped the container. To remove those error messages, I need to specify a couple of flags for the Podman, or I can also configure the Podman globally, changing the Podman configuration. But in demo purposes, I just want to show you how to do this using the small flags for the Podman command. So I return to the same command that we used to run our container, and I just want to specify the two additional flags. The first flag will be cgroups manager, cgroup manager, and I will say that I want to have the cgroup fs. The cgroup manager, it instructs Podman what manager for the cgroup it needs to use, and the possible values for cgroup manager is cgroup fs and the systemd. And the default is the systemd, but because I don't have a systemd, so I specify the group fs. And the second flag that I want to send to the Podman is events backend, which equals to file. Events backend flag instruct Podman which backend it needs to use to store the events for the containers. And allowed values are files, journald, and none. By default, it used the journald, but unfortunately, because I use the WSL tool, I don't have it. So I just specified the file, and it means that it will store all the events inside tempdir, which is by default, it's a var tmp folder. When I specify those two flags and I just execute the command, as you can see, we have our container ID with no error messages anymore. So because the Podman will not use the systemd anymore and will not use the journald. So, and if you do the Podman now with command ps, just to see what containers are run, we will see that we have our simple app version 1.0.0 running. The last thing that it's left is just to test it in our browser. As you can see, we map port 8080 to 80. So, and now I return to my browser and I go to the localhost port 8080. And of course, I will see my application, which is up and running. So we have privacy, we have home, and actually it's run using the Podman now, and we build our image using the Buildah. In this episode, we actually built our image using the Buildah, and we have seen how it's easy to use the Buildah with existing Dockerfile. So actually just one maybe minute to change your script to run from Docker to Buildah. And we use the Podman to run our containers, and we also have seen that it has the same commands as the Docker. And that's mainly it for today. Thanks so much for watching. If you like video like this, please give me suggestions about the next videos that you would like to see in the comments. And please do subscribe. Thank you so much, and see you in episode 2.